The problem with this one is, in this example here, the problem is that if I let u equal x squared, which is what I do, in fact, and differentiate it, the differential of x squared is 2x. X has not disappeared. But if I differentiate again, the differential of 2x is 2. So if I apply the rule twice, I keep going until x disappears, and then I can do it. So let's try this example and do that. So we're going to apply the rule twice, which is a good example of using the rule, because we'll go through it twice and you'll start to get the idea. So, same, I let u equal x squared, and I let dv equal sine x. So the bit I call u, I differentiate. The bit I call dv, I integrate. As a little aside, differential of u is 2x, the integral of sine x is minus cos x. Don't worry about the c till the very end. So that's easy. All I have to do now is plug them into the rule. So the integral of x squared sine x, my original integral, equals uv, remember the rule, uv minus integral v du, so u is x squared, v is minus cos x, minus the integral of v, which is minus cos x, du, which is 2x. Let's tidy this up before we go any further, because there's all sorts of signs going on in here. I've got minus minus here, so that's going to make that positive. And I've got to do something about that integral because the 2x hasn't disappeared. And this is negative, so let's put that second. So let's call that the integral of 2x cos x minus x squared cos x. So just tidy it up. Now I do apply the rule again. I let u equal 2x and I let v equal that. So let's just worry about this bit. And we'll add the minus x squared cos 2x at the end. So saves us having to keep rewriting the whole thing. So just worrying about the bracket, the integral of 2x cos x dx equals, oh well, I'll edit that little bit out on video. Of course, whatever I call u, I've gone wrong there, haven't I? That should be dv, shouldn't it? Not uv, I'm thinking about the product rule. dv. So whatever I call u, I differentiate, and whatever I call dv, I integrate. So du is 2, great, because x has now disappeared, and v is sine x. And then we just plug them in. So for the bracket, the integral of 2x cos x equals uv, so that's 2x times sine x minus the integral of v, which is sine x du, which is 2. And we've now got an integral we can do. X sine x. Integral of sine x is minus cos x. So, times 2. Minus minus is plus. 2x sine x plus 2 cos x. But that's the bracket. So that goes back into here. Into here. And then we can finish off the overall integral. So going back to here, my original integral, the integral of x squared sine x dx, equals this bracket, which is this, 2x sine x plus 2 cos x minus x squared cos x. Just apply the rule twice, and I would probably try and factorise that to some extent at the end there. Maybe partially factorise. Take a 2 outside of the first 2 terms and leave the last term. How I factorise it would depend on what you want to be left with. It might be convenient to factorise the cos x term out, or it might be convenient to take out the 2. It's up to you. Quick